let's hear about Bee Hero. If you're ready.
Sure. Yeah.
And maybe a little bit about, just maybe a little about your background too, and sort of how you came about Bee Hero first, or where it came from, because you're one of the founders, right? Or the founder.
Yeah.
So yeah.
Yeah, sure. And I'll probably touch some of the things that David mentioned, because it's the same challenges, mapping the specific users and customers, and like trying to tie some sort of a commercialized path for this. So I think this is where we can probably have even a deeper discussion. Briefly about myself, I'm not a beekeeper, I'm not a farmer, I'm a data scientist. I'm actually coming from the cybersecurity world. The accent is from Israel. I'm originally from Israel. For the last 3 years, I live in California as part of Bee Hero efforts to grow and to expand. Before Bee Hero, I worked with the Israeli Cyber Center for a few years on some interesting projects, and later on, I shifted towards entrepreneurship. I founded 3 companies before Bee Hero in the field of energy recycling, in the field of retail, and in the field of aquaculture. I sold 2 of those companies. I closed one of them. So I've seen, I guess, both sides. And then a little bit more than 4 years ago, I met one of my co-founders, Itai Kanot, who is a 2nd-generation commercial beekeeper. His family owns the largest bee farm in Israel. They run approximately 5,000 or 6,000 beehives. So in Israel scale, that's like the biggest. In the US scale, that would be like a medium size, I would say, beekeeper. And I was just intrigued with, colony collapse disorder, and in general, the fact that bees are moving on tracks. Like this was new to me. Maybe for everyone here, that was like a known thing for many years, but I didn't know about all the implications of colony collapse on pollination in general. And one of the things when, we were trying to dive in, and I really wanted to learn more about the problem, and luckily I had Itai who can, communicate with me and like give me the insights on the industry in general, is try to identify how come we don't see, big winners in the hive monitoring domain. And we contacted several companies that we've seen back then and tried to identify why everyone is shifting towards the hobbyist beekeepers. Like, why is it so challenging to gain some sort of a traction with the commercial beekeepers? And one approach is to say, yeah, everyone will wrong, we can do it right, and usually that's not the case. Like, there's something inherent in this concept that we need to better understand. And we decided to put some more focus on pollination in general. So we understand that there's a problem with bees, and we understand that the beekeepers, especially the commercial beekeepers, are basically the core to the presence of bees now in this, like supporting crops in general. And the big question is, can we build some sort of a holistic solution that can support the efforts of commercial beekeepers, but can also translate to improvement in pollination, because that might generate a different path that will allow, some more engagement with commercial beekeepers. And we develop those sensors. We focus on in-hive sensing. So I think part of the discussion, David, I think is interesting also, where do you collect the data from, which is so different. Like we can talk about so many challenges, in just deciding where do you want to put the sensor and what kind of parameters you want to collect from the hive. So you start, and I remember actually this discussion, you're trying to get shortcuts all the time when you build a startup company, because you don't have a lot of resources, especially at the beginning. And we contacted a lot of those research facilities, and we said, okay, we want to see data. We want to play with data. We want to see if this is what we want to dedicate, our near future towards. And the level of data that we've managed to see at this point was not very significant. Like, very comprehensive experiments were done on like 8, 10, 12 hives. I think David maybe can share some of his experience in this, but it was just not enough. So in some areas, you can focus on very precise measurements, like extremely precise measurements, and you can do it on small scale of sample set, like 10, 12 hives and so on, and you might get to conclusions. but this means that we need very expensive equipment with the complications of commercial beekeepers, and the challenges of being profitable and mortality rates and so on, goes back to expansion. Everyone wants to drop labor costs. Like David, I'm sure they want to drop labor costs. It's just how much they trust the technology to make it a big difference, how many years it's going to take them to validate the ROI, and what's the risk they're taking. So do they need to pay for the equipment now, let 30% of their employees go, and then, oh, it doesn't work, what I'm going to do? And getting employees today is quite challenging. So we were looking for more of a low-cost technology, low-cost sensors that can collect the data, and this means you want to see tons of data. So we started to build those sensors, those in-hive sensors, and to collect different parameters. And going back to what one of the things David mentioned is, you need to know what happens with those hives. So you can see, and I can show you some like interesting behavior inside hives, but then if you don't know what actually happened, that's very tricky. And we had, commercial beekeepers that we worked with, and we equipped those hives with the sensors, and suddenly we saw like weird behaviors. And we went back and we asked, like, did you know what happened in those hives? And we're like, no, there was a team visiting there yesterday and they did some things I can check out, but you couldn't get a really good indication of what's happening. And we decided that we need to put more efforts in order to build this data set. One of the things maybe worth sharing with you, if I can share the screen for a second. So part of this effort is trying to gain more insights on pollination in general. So this year, like I can talk about some other things that we do. Again, depends on where the conversation is going to go. But this year we decided we're going to do something in a different scale. And we took 1,000 hives across the entire Central Valley of California, where now it's pretty much the end of almond pollination, but like for the big pollination event. And what Bee Hero actually sells today is pollination services. Like we engage with growers and we sell pollination as a service with the supply of hives of those commercial beekeepers that work with us, where we involve the technology and work together in order to improve those hives. And we decided that we need to understand more about pollination. Like we want to understand how can we actually optimize the process. There are more and more acres of different crops out there, and we need to utilize those hives in an efficient way. And we build 10 Sentinel stations across the entire Central Valley that are heavily equipped, not only with the in-hive sensors and the gateways that later on uploads the data to the cloud, but we also use bee counters and scales and weather stations in those different environments. And we did like intense inspection to make sure that we understand every single moment what happens in those areas. And we opened this Sentinel station, which I can later on share the link and you can all access. It's now pretty much end of pollination, I think, for most of the regions, but giving growers and beekeepers real-time data. It's like insightless. We are not doing any analysis on this data yet, but collecting real data from the different regions to try and identify what's happening. And we can see, bee traffic. We can see the gain in weight. We can see the activity level. We can see how wind and different parameters affect the pollination activity. And now part of our efforts is to see what kind of insights and new findings we can retrieve from those things. And I think this is part of the efforts. It's one thing to identify that the colony is not good, and it's another thing to say what's the problem with it. And maybe going to some of the work that we've been doing, and I'm sure David faced it as well. There's a lot of uncertainty about the things that you can determine from inside the hives, or even from collecting data from hives. And if we take it to the extreme, it's easy, but we're also trying to use the right words when we want to talk about the vision of what we do and so on. And David mentioned the things that we do to the sound eventually are pretty much the same methods. It's a question of, can you get precise data? Can you train enough data points, and then is it accurate enough to be used in this specific channel that we want? And we work in 3 different layers. So when we collect data from hives, we're trying to compare the hive to itself, like to understand, okay, this specific hive used to behave in a way. Let's look at brood temperature. Okay, it's a simple thing. You don't need to be an expert to know that, you know, the hive will try to maintain a certain temperature to maintain the brood development. And if this temperature changes by like, you know, 4 or 5 Fahrenheit degrees, it means that it affected the brood in a way. And this is something pretty easy to measure. But then you start to see some interesting behaviors like, you know, this specific hive, there's a hole in the lid of the hive and there's wind coming. So suddenly the change in temperature is not really the change in brood temperature, it's just the change in the specific location where you put the sensor and so on. And those are the challenges that we need to deal with every day. So we compare the hive to itself and we try to understand if something significant has changed. Then we compare it to the specific yard, because we know that this specific yard is facing the same environmental parameters, the same foraging activity, and so on. So we expect them to behave in a certain way. And then, of course, you have the largest data set of beehives and labeling that, like, scenarios that you've seen before, and you're trying to identify, is it close enough to this thing I've seen? And I think the more hives we have, we probably encounter 2 main challenges. The first one, reception. You know, when we started with, like, I know 20,000 hives, you know, we could have picked the areas where we want to monitor those hives, and the data flow was good, and it was easy in a way. And now we're getting close to 100,000 hives, and suddenly you have areas where you cannot really get the data. So you need to change a lot of things in terms of, you know, locally collecting the data and waiting for the next, you know, team to visit the yard, and then the app can pull the data and upload it. So you don't get real-time indications, but at least you get a good indications of development on those yards. So this is part of the challenges. And the second thing is, you know, how motivated, or at what point, I would say, you want to provide the insight. So part of the things that we do when we don't have clear indication on what the problem is, we'll say this hive is declining. Okay, if we want to take it to a simple measurements, let's assume that the hive can maintain a certain temperature of brood. And again, I focus on, like, the simple thing because I think that's the core. But then you start to see a lot of variation in the brood temperature. Like, something is not good. It's either the queen is not laying eggs, or she's laying eggs in different areas of the colony, and the colony is struggling to maintain temperature. Maybe they don't have access to water to cool down the hive, or maybe there are not enough bees to heat, or maybe there's, like, too much volume in the colony. So there could be so many things that affects, could be specific disease. And then we say, okay, this hive is declining. And, you know, at the beginning, we got beekeepers go there and open the hive and say, no, I don't know, it looks okay. And we say, no, something is wrong. Like, we see the data, something is wrong. So no, it looks okay. And then the next time you see, sometimes those hives are dead already. So it's really hard to identify how can you build credibility when sometimes you see indications earlier in the process, and sometimes you don't even know what the problem is. You just know there's a problem. And part of the effort, and that's not a technological play, that's a product play, like to try and identify what's the right time to give an indication on a certain issue. And for most of the things, it's not that complicated. To understand foraging activity, you can track specific vibrations of the hive when it hydrates the nectar. So that's like a good indications to know how many nectar was collected in the previous day. And we can look at specific graphs and see it's not. The fact that there's so much change between different hives, and the methods of different beekeepers is so different. I think this is where the biggest challenge is, and like that's reality. This is what we need to deal with. So yeah, I have a lot of things to share, but I'm happy to try and answer the things that interest most of the people here.
Great, thanks. Any questions out there? I haven't seen. Thanks for that clarification, David, as well in the chat. Any other questions? Unmute yourself, jump in. So I'll let, you've got other things to chat about. We can go that direction, but I was kind of curious about, so you talked about, and this is something similar I heard in David's presentation as well, is sort of identifying that marketability or that thing, you're doing this activity of collecting data on bees, which, as you just explained, is extremely challenging because of the complexity and the number of different variables that are going on. Yet you recognize, okay, pollination might be something we focus on because there's a value in that. That's the value proposition, is to say, okay, we know farmers definitely need pollination, and they know they need it, and they're willing to pay for it, which is what they do now when they rent bees. So are you seeing sort of the connection, or maybe explain all this data you're gathering, you're starting to pull together the health of the hives and foraging and so forth, how that's starting to connect to your value proposition of pollination?
Yeah, so I think if we even go one step, backwards, you try to identify whether your solution needs to suit, hobbyist beekeepers and commercial beekeepers, because that's a different thing. And hobbyist beekeepers, they don't want to know what's happened in the hives. They want to open the hive. They want to look at it. They want to see it. They want it to die and then to fix it. And it's a pet. I know some of us who has dog probably want someone to take the dog out from time to time, but you don't get a dog, so everything will be done by someone else. So I think this is part of the hobbyist interest, and this is where you can build different kind of solutions. When you focus on commercial beekeepers, you want to focus on the things that will make a change to the unit economics, whether you can allow them, to reduce labor cost, or whether you can help them to save, some of the colonies, reduce mortality and stuff like that. And we're working very, very hard to try and identify, okay, how much will it cost? So let's assume we have this solution, and we don't want to think, we don't want to complex anything. We don't want to talk about pollination. We want to focus on commercial beekeepers. And then you can come up with, different range of prices from, I don't know, $1 a month per hive to, $5 a hive per month. And now everyone can do the math. And then they'll say, okay, so I'll put it on 20% of my hives. It starts to create some complexity. And I still don't think that's the biggest problem. I think the biggest problem is scalability. How fast can you scale? So let's assume every beekeeper I'll meet will probably, I'm talking about, let's talk, 500 hives plus. They'll have 1 yard equipped with sensors. They don't care how much it costs. It's just 1 yard, and they'll do it. And then we want to run for a year and see what happens. But yeah, maybe that was not the right year to measure it, because this year there was frost and we need to so then let's do another year. So we might expand from 40 hives to 80 hives and so on. That's not scalability that can exist in the startup world. Like, if you want to go and talk to investors and bring Silicon Valley money into this industry, you need to show that you can expand much faster. And without this money, it's very hard to develop. David is sharing the same challenge. We need resources in order to investigate things that we don't know. So the focus was to see how we can build a model that can scale fast and can also generate, good ROI for the company. And our focus was to look specifically at pollination and the fact that there's so much volatility in hive strength. So when you take hives for pollination, if you talk about almonds specifically, if you put 2 6-frame hives in a field, or you put 1 12-frame hive in a field, you might actually get more foraging activity on a 1 12-frame hive than 2 6-frame hives. And if you can now build a model that allows beekeepers to improve the quality of their hives and put more frames per hive, maybe you can use less hives in order to pollinate the same amount of acres. And this is the ROI that you really want to see. So this is our investment. We can now bring money from external sources to invest in a technology that will shift the trend from the quality of hives that we see today to, even double, ideally, the number of bee frames in a hive. And then we can service the same amount of acres even better with less resources. Now, it's not a question of, okay, now you don't have as many hives. The number of new acres, the expansion on the needs for pollination is much more significant than the change in bee population. So we're actually supporting the expansion of the industry. And suddenly the commercial beekeepers are way more flexible on expansion, because they do not need to take money out of the pocket day one. Actually, they don't need to take money out of the pocket. They get the sensors, they get the access. Sometimes when you don't pay for something, you're not as engaged. So that might be a problem. So we might alert on a specific problem, but no one will go and visit those hives because, yeah, we're going to meet it in 2 weeks anyway, and so on. So there are some downsides to this model, but it allowed us to create a model that took us from, I know, 0 hives by the end of 2018 to 100,000 hives in 2022. So at least we can scale fast, which is the first challenge. Now it's a question of, how well can we improve the unit economics, and how can we generate a model where both players in this equation wins?
Yeah, thanks. Hey, Rachel, I saw you maybe had a question.
Oh, yeah, mine might be more for David, but I guess I was just kind of wondering, like how helpful listening to colonies is for diagnosing like health problems, and whether you like how you go about kind of testing that, because Omer also, mentioned there are a lot of different things to look at in a hive, right? And so I'm just wondering, like, yeah, how that technology like distinguishes between things, and whether it's like it's the only metric you need, really. Yeah, I was just curious about all of that.
I'll jump in on that. That's a great question as well. And that's the complex. Omar did a really wonderful job actually on talking about kind of limiting the variables, and there's so much going on. That's the issue with bees. And so we do know that bees make a different sound when they're sick. That's unequivocal. And we believe, and we've found that with each different disease, and we have 7 or 8 in our app, it's a different sound that they make based on the disease. Your question is, hey, what if they have 2 things going wrong, right? Yes, that becomes more complex. And that is our artificial neural networks, our AI, artificial intelligence, actually does work on that. So we can use the technology to tease that apart. There's a way to do that. But Omar even mentioned it. It's like, what if it's windy where you put the colonies? And what if we know water is a huge issue, actually. Our preliminary findings, if we didn't get to a research level on this, is that a lot of colony collapse disorder was actually lack of water. We saw a strong, our research found that it was a fungus and a virus. But we also happened to notice that it depended on drought as well, which, we didn't measure actually, which is why we couldn't do any real research on it. But to your point, Rachel, yeah, this gets really tricky, right? If your colonies are in a windy area or not windy area, if they're near water or not near water, everything changes. Everything changes based on just water, never mind all the rest. And it could be whether you have them south facing, north facing, there's tree cover, there's not tree cover, because obviously if there's tree cover, they don't lose as much water. If they're not, they lose a lot. And so, yeah, it sounds simple until you realize that there's a lot going on. So.
Yes, maybe I can add to this that, our efforts and focus to try and collect the data from inside the hive was based on the assumption that, we at least can control some of the environmental parameters. But then you see like other issues, someone is putting the pollen patty on top of the sensor and suddenly it, affects the sound and like different things. But even just like to give you, to show you some, like a small example, what you can see here, that's basically the level of energy in different frequencies. And you can see that like different hives will behave differently. And if we look at those same level of energy across the entire day, like 24 hours, you can get good indication, that's actually 48 hours, you can get good indications about the different activity level. And everything you see here, that actually comes from inside the hives, because the focus inside the hive, like the different job that you do inside the hive, changes based on what happens in this day. So at the beginning, you might have a lot of foraging activity. So bees will go out and come back in and so on. And then later at night, they will focus on hydrating the nectar. And then if they don't go out to pollinate, then you'll see less foraging activity. And based on those changes in patterns, you can get some good indications on what happens. identifying those outliers, exactly like David mentioned, I think it's the challenging part to know, okay, is that an outlier or that's a biological behavior that we need to now explore further? And how can we generate a non-intrusive scenario that will allow us to keep seeing this thing? Because I know when we first started, we wanted to see how the colony reacts when the queen dies. So like one way is just to remove the queen, or another way is, to smash the queen and to see what happens, like different things that will allow you. But in all those cases, you intervene. And when you do something, you don't know if the data is now authentic until you see enough scenarios of, like, let's call it naturally queen failures, that then you can say, okay, this is authentic patterns that I can actually trust when I make this assumption or insight.
Angela, I see you're off mute. Do you have a question, or you want to?
No, no question.
No questions.
Nope.
Hey Omar, how much are the commercial beekeepers renting out one colony, one beehive for these days? I know it's for a 2-week period, right? How much do they get to charge for 2 weeks for one bee box?
So yeah, I mean, if we talk about pollination, we keep seeing the prices, increased. If we look, 10, 15 years ago, it was like $20, and now it's around 200, sometimes even 220. I think it's a combination of, shortage of hives, cost of logistics, which is quite significant, especially for those coming from out of state, and yeah, the labor intensive work there. So I don't know exactly the prices this year, but I think the range would probably be around $200 a hive. But then again, that's like the first, maybe most significant, but that's the first pollination of the season. Then they'll go to pollinate apples in Washington, and some berries in like different areas, Oregon and Maine, and then come back to sunflowers and more like row crops where you can still make combination of honey and increase in yields. Yeah, and honey prices is also a big question for commercial beekeepers, because I know it changes every year. You cannot really trust the honey prices in terms of revenue stream. We'll have to see now with everything that happens in Ukraine and the cost of gas, how it's going to affect the industry.
Any other questions for either speaker? Omer, I've got one. So you were talking about the scalability and the challenges of scaling in the hive or the professional beekeeping market compared to like what you might find in technology in the Bay Area or something like that. And that certainly is something we confront in Montana all the time with all kinds of startups, because we often are doing projects or startups here that don't have that same kind of very, very fast scalability. So obviously you think there's great opportunity in this, and you're driven by the passion of working with bees and supporting bees and so forth. But how do you navigate that difference of scalability when you go to talk to investors? Is it a challenge around saying, hey, yeah, we're not going to be this very rapid growth kind of company like Uber or something, but we have a mission and we have goals and we're very viable. So here's our value vertical to you.
So I think we start to see some changes in this industry. Like if you see the increase in investments in agricultural space in general, on the startup side, you'll see the biggest increase. It's still not a significant amount of the money that is invested, but the trend seems to be positive. I think that I would say the normal venture capitalist is struggling with investment in agriculture. It's a different ROI model. There's a question of expansion. There's a question of validating the assumptions. Especially those guys who talks about increasing yields. How many years, how many acres do you want to see consistency before you actually trust that you're the reason for yields to increase? And I think also, I would say the visionary story of entrepreneurs is not going very well with boots on the ground farmers who wants to no bullshit, basically. So that's an interesting transition. I think we try to focus a lot on strategic investors, and I think those guys do understand. So, if we have ADM Capital and also Rabobank as strategic investors that understand agriculture probably better than me, they understand that the ROI or the life cycle of startups in this industry is a lot different from the cybersecurity world that I used to work with, and like it's just different, but the impact is quite more significant. So I think it's first of all a question of identifying the relevant investors, those that do understand. I guess maybe the tricky point, and I really faced it on the beginning of the company, that you go and you meet a traditional VC and you talk about bees and pollination and agriculture, and it's so new to them. So they want you to meet all the partners and you feel like, oh, it's going well. They're really interested, but practically there's no chance they're going to invest in it. It's like, it's too far from their sweet spot. So there's no chance they'll invest in it. I think the focus is to try and to bring those investors that actually understand it. Sometimes they have their own network where they will open you doors, even to validate some of those assumptions. But I think the biggest question is how can you build proof of concept in the most efficient way in terms of time and resources, because some of the investors, actually even ADM that led our Series A like a year ago, I've met them in the past. It was just too early for them. They were like, okay, like we want to see what, we believe in it. We understand pollination is a big deal. We understand the problem of beekeeping is a big deal, but we want to see some more traction. Like we want to see that you can actually nail it and figure out the dynamics in the market. So I think this is the main challenge. And I think you need to reflect in a very clear way that this is how agriculture looks like. If you have a way to shorten the cycles, that's great. Like try to build collaborations in order to shorten the cycles. I think that's great as well. But try not to oversell. And it's very different from the cyber world, I can tell you for sure. I'm still adjusting.
Yes, thank you for that. I think that you explained that beautifully. That's something we're challenged with a lot in this space of ag tech and the cycles. Like oftentimes if you're working in agriculture, we talk about in tech industry, iterate a lot. Well, in agriculture, you get one iteration per year. And so you can only iterate so much in 1 year, and you find out, and then it could be a whole variety of things that change that. So I don't know if David, if you had a thought or comment on that too, through the ICOR program and in your work.
Yeah, I mean, the ICOR program really is about figuring out who your customers are. So, I mean, Omar brought a really different perspective there, but I was certain it was backyard beekeepers that were our market. There's 100,000 of them. How can most of them not want an app that listens to bees, right? And I was the one who did most of the conversations. It was wonderful to hear that they think of their bees as pets, and really annoying to hear that they had no interest in technology to help them, right? And so that's what the ICOR program is about. It's really not funding. It's all about understanding customers, and where you add value, how you can help them solve a problem. And so that's the perspective we were coming at it from. We were super lucky. That's what the ICOR program is all about, though, is finding that kind of aha moment where you find someone who actually does want the technology you have developed. Really, you should do it the other way around. You should find a problem and solve it. We had the solution and we had to find the problem. So we were sort of going backwards, which happens a lot, it seems.
Yeah, I don't know, you want to say something, Omer?
First of all, I have a question for David, and also I put another comment on one of the questions that like people were trying to calculate the turnover of beekeepers. The operational costs are quite significant, so don't assume that they're the richest people you know. There's a lot of expenses, and if you move from 30% mortality to 50% mortality 1 year, then you're suddenly losing money. So I think in general you need to be aware of all the parameters before you make any assumptions on this. And also, David, I did want to ask you if I think the part of what you've mentioned with big tech companies or like big organization trying to get involved in this impact and renting those hives is the plan is to try and build some sort of I would say, marketplace or a platform for those corporates to engage with those beekeepers that you have on your platform, or are you looking to, you know, work directly with the beekeepers?
Yeah, that's a great question. So I don't know if we're there yet is the problem. We should have been, because we were supposed to do this fall 2018, right, when we couldn't. And so our next steps are going to talk to people who do this professionally, and then we're not sure what happens next. We're not sure if we want to go direct, do the platform, build the community. I mean, everything you just said made all of those are really interesting options, which we haven't gone there yet. We're still figuring this out. So
Interesting.
we have the tech, we have the customers, we think. How to bring those two together is the next interesting part. So we need to talk to people. Again, that's the ICOR program. It is talk to the people. And so literally the money we got from the NSF is to go and visit people. I mean, it was almost all for travel, which is great when you get that money June 2018 and you have 1 year to spend it. They extended it out an extra year and a half, actually, it was 2 years, which was great. But yeah, we need to go and talk to people and figure out what the next steps are. Sorry, I wish I knew the answer to that. And by the way, Omar's right. I just want to point that out. You know, any commercial beekeepers, backyard beekeepers, everyone loses 20 to 40% of bees every year. It's just the nature of things, right? And so there's that, and all of those need to be replaced. That's why they have all these professional beekeepers on staff. There's a ton of cost. They've got to drive, as Omar said, they've got to drive to Sacramento area and then to Central Coast, California, and then up to Washington. And when you're trucking 10,000 bees at a time, you know, it's a lot of equipment and it's a lot of cost. So.
Well, thank you both for coming up on 1 hour. Any last questions out there? Comments, thoughts? Been kind of a quiet group today.
We were either very clear or very boring. That's
Yeah.
the two options.
Well, actually, I think, I mean, one last thought here is that you both kind of pulled together two pieces, put the string together here of one, you know, Dave was talking about the ICOR program, talking to customers, making sure you've got a market, actually proving out that there's a use case, a customer, and hopefully a bunch of customers that want to have the thing that you are doing. And as complex in finding out the data to create the product it's also very complex to find out, or challenging to find out the data on the customer. And Omar, as you were pointing out, you know, looking and showing and proving to, if you're going to go try to find venture capital or financing of any kind, they need to see that proof, right? They need to say, okay, hey, show me, one, you can gather the data complexity of the system that you're working with, and then two, you have the customers and the revenue that will sort of scale, at least within the direction and our expectations of the market that you're in. And agriculture is unique. It's different than anything else. So even though we're technology here, it really, the scalability is with inside the environment of agriculture, which I think is really important for everybody to remember in this space. But I thank you both. That's a very, you know, you told a wonderful story today, I think, from different directions, and shared your technologies. We're right at an hour. Yeah, thank you. And any last parting thoughts? Yeah, Rachel.
Oh, I just wanted to say thanks. I thought it was a great talk. Yeah.
Yeah, thank you both, David, Omer, and David.
Thank you. Thank you for having us.
Of course, we'll be posting up there. We'll be sending it out. We'll send it to you as well if you want to share it in your social media and what have you. You're welcome to do that. But
thank you so much.
Have a great day, and go look for some bees.
Save the bees. Bye-bye. Thank you.
Thanks, everybody. Take care.